All right, in this video, what I want to do is show you the R commands for chapter 7. The idea here is we have our data set. So this is the example that we went over just in this video. We have the set containing the sample. Well, the sample is 1, 4, 5, and 8. And we can talk about the mean. Oops. We can talk about the mean, the standard deviation, and that's kind of old news. Okay, so not too much there to talk about, but that's the mean, that's our standard deviation. That's how I got the numbers from the video. Remember that you can do the rounding thing if you want the, say, the standard deviation to 4 decimal places. Okay, so again, that's how I got those numbers from the video. What we're going to do in chapter 7 is we're going to introduce a single function, and that's the combination function. So COMBN. And what this is going to do is it's going to tell us, take our set X, which has those 4 numbers in it, and look at all the pairs of elements, or look at all the, in other words, we're grouping 2 elements from the set at a time. And like I said, there's going to be 6 of those. And so that's what the set, this is the combinations using the data set X, and these combinations are of size 2. And there's 6 of those because 4 choose 2 is 6. So there's 6 of those. And what we can do is we can look at the means of each of these. Now we do not need to find the means by hand. What you can do is there's a nice code here if you just put in mean at the end. So notice that I just took our combinations of from our set X of size 2, and then we want to compute the mean. And what that'll do is that'll spit out, I'm going to call this set Y, but that spits out the means that we were looking at before, 2.5, 3, 4.5, 4.5, 6, and 6.5. Okay, and it turns out that if you take the mean of the data set X, you get 4.5, which we knew. And if you take the mean of this set Y, this is the mean of the sample means, you also get 4.5. And this is what we knew. As long as we have samples that are all the same size, this will always work. So for example, I could have picked Z to be the combinations from X of size 3. There's going to be 4 of these. Okay, so those are the 4. The reason why I know that there's 4 of them is because 4 choose 3 is 4. And again, you could look at the combinations of X of size 3 and the means of those combinations. So in other words, we take 1 plus 4 plus 5 divided by 3, 1 plus 4 plus 8 divided by 3, and so on. And if we do that, these are the values that we get. I should actually call this, let me call this set Z. So I'm going to redefine Z. So Z is that set. And if we take the mean of Z, do you know what we're going to get? 4.5. Okay, because it's the mean of the original data set. That's just how that works. The other thing that we said is that the standard deviation of the sample will approximately be equal to the standard deviation of our underlying sample divided by square root of n. So let's go back and let's think about, we had our set X, which was 1, 4, 5, 8. We had our set Y, which is 2.5, 3, 4.5, 4.5, 6, and 6.5. And it turns out that if we look at the standard deviation of Y, that should be approximately equal to the standard deviation of X divided by the square root of 2. This will not be exactly alike. In fact, we started with a sample with just 4 elements, so it's probably not going to be that close either. Yeah, and they're not really that close. But as X gets bigger and bigger, this gets to be a better and better approximation. So let's do an example where we have a larger set. And what I'm going to do is I'm going to use a code that I haven't talked about so far, but let's say we want 20 values between 0 and 1, and these are going to be uniformly chosen. So this is going to be 20 random values uniformly chosen on the interval from 0 to 1. Okay, these are the 20 values that it happened to pick. This value is really close to 1, which is not important. It's just mildly interesting. Anyways, so these are the 20 values, and what we're going to do is we're going to do this game again. We're going to look at all the combinations of size 2, and we're going to take the means of those combinations. And there's going to be 45 of these because 10 choose 2 is 45. Remember, 10 choose 2 by definition is 10 times 9 divided by 2. So that's 5 times 9 or 45. And we know that the mean of the original data set X, whatever it is also going to be the mean of our set Y. Okay, so those means are going to be the same. And then the standard deviation of x, being 0.278, should be approximately equal to the standard deviation of y divided by, I said this backwards, the standard deviation of y being 0.187 should be the standard deviation of x divided by square root of 2. This will be closer than we were before, but still not exactly perfect. And as the number of data points that we pick goes up, let's do one where we have, say, 100 data points. So here we're picking 100 values uniformly on the interval from 0 to 1, meaning that in that interval, you can think of it kind of like a rectangle, and then we're just randomly picking a value anywhere in that interval from 0 to 1 in that rectangle. We're going to look at the same combinations. And then let's look at of course, we can do the usual mean trick. So the mean of each of these sets should be the same, but the standard deviation. So if we look at the standard deviation of y, that's 0.203. I don't know what the standard deviation, well, the standard deviation of x is 0.2910. And what I really want is the standard deviation divided by square root of 2. That should be really close to 0.203. And we're getting closer and closer and closer, so it's 0.205. And again, if we had more values, say if we had 1,000 values, this would be closer and closer still. Okay, so those standard deviations of the sample and the standard deviation of the set of the sample means are going to be related in that way, whereas the number of elements in our original sample increases, those get closer and closer to each other. Okay, so this is really all that I wanted to talk about as far as R in chapter 7.